So with that, I will take any questions that people may have. The first question is, does the TrueAllele system come with a genotype database? Yes, it does. It operates in the background. Within cases, it can be configured to do any of the things that we talked about, but then it's being set up in order to do constant background matching between cases or between different parts of the database and not within a case. The next question is, what data did you use in your AAFS talk about genotype databases? The data we used was taken from an NIJ study that we conducted almost 15 years ago, and it involved two-person mixtures of different mixture proportions and different amounts of DNA quantity, and that was the starting point. We had manually scored that data at different thresholds, as well as analyzing it in TrueAllele, and that meant we could make database comparisons using different CODIS rules and identify what the information that was found, as well as particularly the error rates, the false hits, the false negatives, and so on. Next question. If one mixture hits many profiles on CODIS, how can TrueAllele help? Well, that's exactly what we saw in the Stewart-Burton case, where we saw that the values could be stratified left to right based on, suppose you get 13 hits back, and now you look at their log LR values relative to the original evidence that's now computed as a probabilistic genotype, a single contributor that has probability. It can be sorted out so that some of the matches have lower values, some have higher values, and by analyzing the contributor in TrueAllele and looking at the non-contributor distribution for matches, what happens to this inferred genotype when it's compared with non-contributors, we can get a sense with tail probabilities or p-values of what's real and a reliable hit, shown in green with a number like 1 in a million, and what are more suspicious hits that may not be reliable or maybe adventitious, here with shown in red with numbers that are greater than 1 in 1,000 rarity. So that's how, if you have many hits in CODIS, TrueAllele and the information part of its system of separating out genotypes and being able to make comparisons with not just likelihood ratios but also other statistical measures can help determine what might be the true contributor. The next question is, can a genotype database become a lab's local DNA index system? If a lab wants it to be, it can be. There's some groups that are doing that or working on that. They're still using CODIS at the ENDIS level in order to take advantage of the 11 million convicted offender profiles that are on CODIS. But at the local level, they may have other needs or other motivations. If their goal is to look at all the evidence, or if the people the office that runs the laboratory, whether it's a medical examiner's office, police, or prosecutor, if their goal is to fully examine all the evidence and make all comparisons and not just look at 10% of the mixtures on a database, then more can be done with evidence-to-evidence matches, with evidence-to-suspect matches, as well as using it for quality assurance, for comparing with staff, and these other applications that we looked at for familial search, missing persons, or mass disasters. The next question is, how does a data-driven workflow help a lab work more efficiently? The answer here is that instead of looking at all possible comparisons equally, if instead what a lab is doing is focusing on where the information is. As Willie Sutton, the famous bank robber, once said, you know, why do you rob banks? And he said, because he goes where the money is. In the same way with information, there's more information in looking at comparisons between evidence where you already know there's a match, as opposed to where it's very unlikely that there's a match. The next question is a bit longer. It asks, when the possible genotypes of the evidence are determined, some of the options include alleles that are not present in the profile, i.e. dropout. The software seems to have varying probabilities for this missing allele. Is the probability of what the missing allele may be based on how frequent certain alleles are in the population? The answer is yes and yes. To compute the probability of any event, such as, in this case, of a particular allele pair for a contributor genotype at a locus, you need to combine prior probabilities with posterior probabilities. The prior probability in this case is exactly what the questioner has asked about. It's based on how frequently certain allele pairs or genotypes appear in the population, which is calculated from allele counts. There's also a likelihood component, which is to what extent that using this allele in genotype allele pair candidates can help explain the data. For peaks that are completely missing, then that calculation is dominated more by the population genotype probabilities, whereas if the allele pair, if those alleles are somewhat present in the data, maybe they have RFUs of 20 or 70, then the likelihood component will come into play as well. Okay, going to ask if there are any more questions. Let me just check and see. Okay, well, there seem to be no further questions at this time. Of course, if you have questions later on, feel free to email me. My email address is shown on the bottom right of the slide. Thank you for attending, and we look forward to seeing you at future webinars. Thank you very much.